Hello everyone. Today in this video we are going to speak about the second module, which is nothing but FET and SERs. In the previous modules we discussed about the module 1, which is nothing but the semiconductor diodes and its applications. In module 2 we are going to study about the FET and SER. And the textbooks that we are going to refer here is D.P. Kothari and Nagarat Basic Electronics, and the other textbook is Thomas L. Floyd. The name of the textbook is Electronic Devices. So what actually we are going to study in this module is first we'll be studying about the introduction to FETs and what is JFET and all. Later on we'll study the construction and the operation of JFET, its drain characteristics and its parameters, its transfer characteristics, and then we're going to study about the MOSFET, its types of MOSFET, and then its construction, operation and characteristic and symbols, CMOS, silicon controlled rectifier, that is SCR, and the application of SCR, which is nothing but a phase control application. So let's start with the thing. So what is FET? FET is nothing but a field effect transistor, wherein which this field effect transistor is a kind of transistor that uses an electric field to control the shape and hence the conductivity of a channel of one type of charge carrier into a semiconductor material. These FETs are unipolar devices, or we also call it as unipolar transistors, where they involve single carrier type of operation. Coming into the basic information about FET, FETs can be called as majority charge carrier devices if the current constituted by them is due to the majority charge carriers, or they can also be called as minority charge carrier devices, in which if at all the current is mainly due to the minority charge carriers. The device consists of an active channel through which the charge carriers like electrons or holes flow from source to the drain. The conductivity of the channel is a function of the potential applied across the gate and the source terminal. Basically, these FETs consist of three terminals. One is source, the other one is drain, and the gate terminal. So the transistor in the FETs, that is field effect transistors, consist of three terminals, namely the source, drain, and gate. Source is the one where actually the carriers enter the channel. Through the source, the charge carriers are going to enter the channel conventionally. That is nothing but the conventional current entering the channel at the source, which is designated by the current IS. And the other terminal is a drain, through which the charge carriers leave the channel. Conventionally, current entering the channel at D is designated by ID, that is we call it as drain current. Drain to source voltage, which is represented as VDC, and the current through the source we call it as IS. Similarly, we have one more terminal which we call it as gate terminal, that is going to modulate, that is the gate terminal is going to modulate the conductivity, channel conductivity, by applying the gate voltage. If we are applying the gate voltage, we can control the drain current ID by using our gate voltage. So in this field effect transistors, we have two kinds. One is N channel FET and the other one is P channel FET. The symbol of the FETs are as shown here. The N channel FET, the arrow mark is inwards. If you can recognize, the arrow mark is shown inwards, and for the P channel FET, the arrow mark is shown outwards at the gate terminal. Let us look into the different kinds of FET, that is field effect transistors can occur as JFET, which is nothing but our junction field effect transistors, MESFET, where it is nothing but the metal semiconductor field effect transistor, and another kind we have as MOSFET, that is nothing but our metal oxide field effect transistor, which are of two kinds. One is nothing but my D MOSFET, which we call it as depletion kind of MOSFET, and E MOSFET, enhancement type of MOSFET. So these are the type of the FETs that it is going to occur. Now let us look into first the junction field effect transistor. What is junction field effect transistor? The junction field effect transistor, again, it is a device which is going to consist of three terminals. One is source, drain and gate, with one terminal capable of controlling the current, that is nothing but which is the terminal which is going to control the current. Current is gate between the other two. So the three terminals as discussed, it is nothing but drain, source and gate. Source connected to N channel and gate which is connected to P channel. The two types of JFETs are N channel JFET and P channel JFET. For the N channel JFET, the substrate, yes, the substrate is going to be N channel and the drain and the source are made up of P channel. Similarly, when we go for the P channel, it is made up of, the substrate is made up of P channel and the the source and the drain are made up of N channel. These are the symbolic representation, logic symbol representation of N channel and P channel. As discussed, N channel, the arrow mark is shown inwards, and for the P channel, the arrow mark is shown outwards, that is the flow of current. So once we look into the channel wise, we have the P, that is the P regions as our source and the drain, whereas in the between we have the N tub, which we call it as N channel. These are the ohmic contacts, that is for the connections that is made, and this is the gate terminal. This is where the depletion region, when we study the working principle of JFET, will come into the depletion region concept. So just for the time's sake, you understand, let us understand that we have three terminals, that is source, drain and gate terminal. So this is what with the representation we have. When we take a simple example of tap, I can say from the source you get the water. The tap, the controlling is done by the revolving of the tap. So that is my gate terminal, and whatever the water that is flowing outlet, we call it as the drain terminal. So this is what is the example for best example for the JFETs, JFET terminals. Thank you for visualizing this video.